Well, I'm hoping that we get 5.1 and 5.2 done before you go to camp. I'm doing this just in case we don't. If you watch the intro/review video, you should watch that first. You attempt to do 5.1 or 5.2, and then I'll do two videos, one for practice for 5.1 and one for practice for 5.2. So 5.1 was about the mid-segment theorem and the coordinate proof. I gave you practice A. I'll do a couple from practice B, which is typically a little harder. Remember, the mid-segment connects the midpoints of two sides of a triangle. So if DE is the mid-segment, it's connecting the midpoint of BC. BD is congruent to BC, and AE is congruent to EC. And what the theorem says is that the mid-segment is parallel to the third side and half as long. So if this is 7, x must be 14. Pretty straightforward. And again, because this is the mid-segment, it's connecting the midpoint of this side. So if that's 8, that has to be 8. And if DE is the mid-segment, if this is 34, this has to be half of that, which is 17. The other part of the theorem is this parallel idea. So if I'm looking at RS, that must be parallel to JL. And if I'm looking at KL, that's a side, that must be parallel to RT. And then JR is congruent to what? Well, again, R, if this is a mid-segment, R must be the midpoint, so JR must be congruent to RK, must be congruent to, and since this is half, this must be congruent to TS. The mid-segment is half the third side. The other part of the mid-segment theorem section is coordinate proof. Place the figure in a coordinate plane in a convenient way. Assign coordinates. So if I have a right triangle whose lengths are 5 and 3, well, I would just put, this could be 0, 5, and that could be 3, 0, and this is 0, 0. That's convenient and it makes sense. This could be 5, 0, and that could be 0, 3. Same idea. A rectangle whose length is 7 units and width is 4. Again, you do the same thing. This would be 7, 0, and then this would have to be 7, 4, and this would have to be 0, 4, and again 0, 0. So convenient way. Again, your rectangle could be tall, so you'd have 0, 7, 4, 7, 4, 0. How about an isosceles right triangle? Well, remember, what does isosceles mean? So these would just be 0, 12, 12, 0. And that would be your isosceles right triangle. 12, 0, 0, 12. So coordinate proof, we're going to see a little bit of that in a moment. This is, before I talked about how sometimes it's easier to think of GJ being twice as big as DE rather than DA being half as big as GJ. So for example, DE is 4x plus 5, and they tell me GJ is 3x plus 25. What is DE? Well, instead of saying 4x plus 5 is 1/2 3x plus 25, I am instead going to say that 2 times 4x plus 5 is equal to 3x plus 25. So 2 times this is equal to that. It's just a way easier algebra problem to solve. 8x plus 10 equals 3x plus 25. Subtract 3x from both sides, you get 5x. Subtract 10 from both sides, you get 15. So x must be 3, but remember the question is, what is DE? So DE equals 4x plus 5. I just determined that x was 3, so 12 plus 15 is 17. So DE must be 17. And let's just check. 3 times 3 is 9. 9 plus 25 is 34. So indeed, this is twice that. And the last thing I'm just going to show you again, because these kinds of things pop up on standardized tests. Here's a little bit about coordinate proof. And I just want you to note that I have a triangle here. And this is h comma k. So of course this has to have the same x coordinate. So it's just going to be h. They're telling you that this is twice k. So if this is negative h0, how far out on the x-axis must I be? Negative h. Same thing. And what must be my y-coordinate? Well, my y-coordinate must be the same as this point and as this point. Okay. So think about the x and y coordinates you're given and how the unknown point that you have relates to those coordinates. That's how you go about solving those.